Case 5, f of x is equal to e raised to ax into v, where v is any function of x. Okay, yp is equal to, in this case yp is equal to 1 upon phi of d operating on e raised to ax into v. Now this e raised to ax into v is operated by this inverse differential operator. Okay, so what is the problem? Problem is we have shortcut case for e raised to ax, or we have a general method to find yp for this v separately. But what about the product? The product is very difficult to integrate by using general method. So we have to take this exponential outside the inverse differential operator. So how we can take? We can use this case. Okay, replace d by d plus a and take e raised to ax outside the inverse differential operator. Simultaneously you have to do both the things. Okay, so to understand this case properly, we will take one example. Example 1, solve d square plus 2d plus 1 operating on y is equal to e raised to minus x log x. This is the problem. So CF, you can find out CF. Okay, we will directly see what is yp. Yp is equal to pi is equal to 1 upon phi of d, that is d square plus 2d plus 1 operating on e raised to minus x log x. Now compare this e raised to minus x log x with e raised to ax into v. So you will get a is equal to minus 1 and v is equal to log x. Okay, now yp is equal to, you have to take this exponential outside the inverse differential operator. For this you have to replace d by d plus a. Now a is minus 1, so you have to replace d by d minus 1. Okay, so d plus a is equal to d minus 1. So you have to replace, take e raised to minus x outside the inverse differential operator and at a time replace. Now this can be easier if you rewrite this polynomial as d square plus 2d plus 1 is, what is d square plus 2d plus 1? It is d plus 1 bracket square. Okay, d plus 1 bracket square. So if you replace this d by d minus 1, then d minus 1 plus 1 will be cancelled and you will simply have d square. So rewrite this d square plus 2d plus 1 as d plus 1 bracket square and replace d by d minus 1. Okay, so your auxiliary polynomial will be now d minus 1 plus 1 bracket square operating on log x. Okay, so yp is equal to e raised to minus x. Minus 1 plus 1 is 0. So if you replace d by d plus d minus 1 here, then calculations will be lengthy. Okay, so to avoid that calculations, you have to rewrite this auxiliary polynomial as d plus 1 bracket square, and after replacing d by d minus 1, minus 1 plus 1 will be cancelled. So simply you will have d square log x. So yp is equal to e raised to minus x. What about 1 by d square? What is 1 by d square? 1 by d works as integration. So 1 by d into 1 by d. It is simply double integration. Okay. Now for log we don't have any shortcut to find out yp for logarithm function. Okay. So we cannot use any shortcut for this. We have to use general method for this. So what general method says? 1 by d is integration simply. You have 1 by d square. So it is double integration log x dx, log x, integration of log x dx. So yp is equal to e raised to minus x. Now is there any formula for integration of log x? No, we don't have any formula. So what we can do? We can use known functions. Okay, known functions, known derivatives we can use. So we know one function of log whose derivative is in terms of log. Okay, and what is that function? It is d by dx of x log x. D by dx of x log x is 1 plus log x. This is the function we have studied from 12th standard. Okay, so x log x, derivative of x log x is equal to 1 plus log x, and you have only log x in the integrand. That means you have to adjust this one. Okay, you can adjust this one in that integrand. You can add and subtract 1. Okay, so it is integration 1 plus log x minus 1. क्या किया हमने यहाँ पे? 1 ऐड किया, 1 सब्ट्रैक्ट किया. ओके, dx. So yp is equal to, now clearly derivative of x log x is 1 plus log x. That means integration of 1 plus log x is x log x. So simply you have e raised to minus x integration x log x for this function, and integration of 1 is x itself, dx. Now you have yp is equal to e raised to minus x integration of, take x in common, so log x minus 1 dx. Okay, now again this is product of two functions in integration. Here you can use uv rule of integration, by parts uv rule of integration, and it is integration of uv is equal to u times integration v dx minus integration of integration v dx multiplied by derivative of u with respect to x, with respect to dx, with respect to x. So this is what? This is integration of v, this is derivative of u, take the product of both the things and then integrate with respect to x. This is the formula. Now how to choose u and v in these type of integrations? You have to choose u, you are differentiating u here and taking integration of v. So choose functions u and v such that u must be easily differentiable, and so integration uv dx okay, so we have to use by parts rule of integration for this sum. Okay, so integration yp is equal to e raised to minus x integration x times log of x minus 1 dx. Now x is easy to integrate, okay, but log x minus 1 is not easy to integrate, because just we have seen log x is difficult to integrate, okay, while finding first integration in the same problem. Now log x is easy to differentiate, okay, and x is easy to integrate. So you can take u is equal to log x minus 1 for this sum, and v is equal to x. Okay, so yp is equal to e raised to minus x integration, take u as it is, log x minus 1 into integration v is x dx minus integration of integration x dx d by dx of log x minus 1 d by dx of u dx. Okay, so yp is equal to e raised to minus x integration of x square by 2, so x square by 2 log x minus 1 minus integration x square by 2 derivative of log x 1 by x, derivative of minus 1 0, so 1 by x dx. Yp is equal to e raised to minus x square by 2 log x minus 1 minus x will be cancelled, okay, So you will have x by 2 only dx. So yp is equal to e raised to minus x square by 2 log of x minus 1 minus x square by 4, x square by 2 and this first half. Okay, so x square by 4. So this is your yp, e raised to minus x into bracket log of x minus 1 minus this 1. Okay, or you can keep as it is. Okay, you have to multiply this by 2, numerator and denominator, then only you can take this minus 1 with this one. Okay, so 2 log x minus 2 minus 1 multiplied by x square by 4. So yp is equal to e raised to minus x 2 log x minus 3 x square by 4. This is your final answer. This is your final yp. Okay, this is just part of calculation, last 2-3 steps. You have to understand the concept of applying the case e raised to x. Okay, conceptual study is important. Okay, thank you.